Today we will be talking about single pole double throw, because a switch can have two options. Like in your day-to-day home, you have single pole on off, but here it can have single pole double throw. So let us see some problems in this, because theory is not much involved. Whatever the theory we have studied in a single pole single throw, it's almost similar, but only problem will change. So the question number 1. In this we have to calculate I of t for t greater than 0. If switch is at position A for long time and then move to position 2 at t equal to 0. So look at this here. Take the problem. I am giving DC, then there is a resistor here, there is a capacitor there, 1, 2, then there is another resistor here, inductor. Call this as R1, R2, L, C, switch is here. Now understand what it says. Switch is at A for long time. So I need to estimate one by one. For example, T0 minus. How is this switch? Switch is here for long time, capacitor, then here inductor. Don't be shocked in my analysis. I generally keep open circuit. This is IL of 0 minus is 0. Why IL of 0 minus is 0? Because this inductor is not connected to supply, whereas capacitor is connected for a long time. Whatever is here will come here. This is R1, this is R2. That's the first idea. And please observe in the problem, this is I of t. What is that he is asking? He is asking calculate I of t for t greater than 0. That means when you keep it on here for a long time, this total comes there. Then let me take you to for t0 plus. Then you have V0 here, R2 here, then capacitor is acting as a battery here, switch is here. This is not changing. IL of 0 plus is also 0. What happened? This current cannot change, this voltage cannot change. That's the whole discussion throughout the chapter. No. That's why this current is also 0. Here current is 0. I of 0 minus 0, I of 0 plus also 0. So first thing is T0 minus, second thing is T0 plus, third thing will be T greater than 0. That means what? Everybody will present. Switch is here, capacitor comes into picture, inductor also here, R2C, R2L here, C here. Then what is happening? Whatever the voltage is here, you can keep it as here. So this is a capacitor having voltage. This is inductor without any current. Inductor has no current, capacitor has full voltage. Though this voltage source is not connected, this is connected. And as we have been saying, this will be called as I of t. That is our step 3. Like I was telling earlier in the lectures, step 1 is t0 minus, step 2 is 0 plus, step 3 is t greater than 0. What is step 4? Step 4 is equation. We have to get the equation there. That is Ri R2i LdI by dt plus 1 over c integral I dt is equal to V naught. What is this V naught? This V naught is appeared there. This is not the V naught coming from here. This is the V naught gone there. Now, what is the purpose of this single pole double throw? Many applications in the industry, we have to charge from somewhere, discharge to another place. So, it has a vital applications in industry, in engineering industry. Therefore, when you put V naught here, you can say 0 to t. Suppose, if you don't put V naught here, you can as well say minus infinity to t, because that is included in this one. Understand? So, minus infinity to is there, this is inside. If we say 0, this is already considered. So, what to do now? You should take Laplace transform. R2 into I of s, L s into I of s minus I of 0 plus 1 over c I of s by s is equal to V naught by s. That is the meaning. I of 0 plus is already 0. That is the link of this problem. Then you can solve for I of s. Step 5 or the 5th point is, if you take inverse transform, you will get I of t for t greater than 0. That is a complete solution of this problem. Calculate I1 of s, I2 of s for t greater than 0. If s is at position 1 for long time and then move to 2 at t equal to 0. This is why you see, when you look at this problem, he is not asking complete solution. He is simply asking I1 of s, I2 of s. Why? Because solving will take a long time. So, in objective question exam, they can't ask. In fact, sometimes they are saying obtain the Laplace transform domain, S domain equations. That is all. Another secret is, if you know the equation, it is an indication that you know the solution. That is why if the equations are correct, answer will come. That is why he is simply asking just the equation. Shall we start our problem? I will start from here. This is V naught. Very good. And he has given one resistor, then inductor, right? Then you have a resistor and capacitor. Wantedly, I have chosen all the 3 elements, please. Even in the previous problem also, I have chosen all the 3 elements. The way we choose, it understands the equation L, C. Now, this is switch. You must observe that this is 1 and 2. In the first problem, switch was here. Now, the switch is here. And this has 2 positions. That is why it is called single pole double throw. That is the meaning, is it? Now, as usual, he is only asking for I of s. That means we are going to take our solution to the 4th step level. Only one step he is asking not to do is 5th step, that is inverse transform. So, as usual, I will take you for the step 1. Step 1 says T0 minus, switch is here, this is here, inductor will act as a open circuit. I will keep it open and waiting for your response. Resistor here, capacitor. We will make it as open circuit or short circuit depending upon our status, that status. For example, always observe the switch, please. This switch is connected. What does the examiner say there? At position A for long time. That means this switch was here. This is R1, this is R2, this is capacitor. Now I am waiting, or we are all trying to understand how much is this voltage. Can you guess? This is not connected to the supply for long time. If this is connected for the supply for long time, it has fully charged. V0 comes there. Then this is not connected. Therefore, this is inductor current is 0. Inductor is not connected to supply. It could not develop any current. No current means open circuit. Capacitor is connected to supply for long time. There is a total voltage. Total voltage means open circuit. Please observe this here. First time both are open circuit. That's why it's always good to understand whether it is connected or not. Now, this is our I1, I2. I1 means here. According to him, according to the problem, I1 is here, I2 is here. Observe the problem. Step 2. When I go for step 2, T0 plus. This is a supply. Resistor is here. Inductor cannot change its current instantaneously. Whatever was there will be there. Capacitor also cannot change its value instantaneously. Understand? So this cannot change, this cannot change. Now where is the switch? Switch is here. Switch is at position 2. Now when the switch is position 2, how is these values? You already saw that. What is the current here? I1 of 0 plus 0. What is the current here? 0. Why this current is 0? Because open circuit. Why this current is 0? Open circuit. Why this current is 0 again? Because this is not allowing. Similarly, this is not allowing. Though the switch is moved from 1 to 2, no change. Why there is no change? It's all because they are not allowing the current to change and voltage to change. Third point, T greater than V0 is here, switch is here, switch is at position 2, inductor is present, capacitor is also present, L R2 C. Now please observe here. Whenever you say capacitor is here with voltage, better say V0. Don't forget that. Capacitor is present with initial voltage, inductor is present without initial voltage. This is I1 of t, this is I2 of t. That's the meaning. I1, I2. Now shall we apply this here? How is the equations coming? In fact, it seems to be 2 loops, it's having only 1 loop. Why? Because this is moved to position 2. So I can easily say one word, I1 of S is equal to I2 of S, because this is nowhere connected to this pot. And then simply apply the equation here, join with me to do so. R2 I of S. I am calling this as I of S directly. I can as well take another thing. So R2 plus 1 over Ci dt plus L di by dt is equal to V0. Then take Laplace transform and finish off this job. R2 plus I of S by Cs plus L into I of S is equal to V0 by S. So he is simply asking you, bracket is here, and solve for I of S, that's all. Why should I say 2? Because both are equal. So those he is asking 2 solutions, as I have mentioned here, both are same. So that's a very interesting concept here. That's about the solution. He is simply asking I1 of s, I2 of s. He is not asking inverse. That's why this is our step 4. Only one step we are missing, or he is not asking. That's the solution. Question number 3. For the circuit shown in figure, switch is at 1 for long time and then move to 2 at t equal to 0. Find I of t. Indirectly, he is asking total problem. He is not asking any step to be skipped. For example, let me start the problem here. No resistor, no resistor, only inductor. This is switch 1, 2. K is generally called key, that's a switch, RL. Actually speaking, this is simply RL circuit, and the current is asking is I. Now shall we start our solution? T0 minus, what is happening? My style is generally, wherever there is inductor, I will open it. I will just write like that. Now I will read the problem again. Switch is at A, switch is at 1 for long time. That means here, if the switch is at 1 for long time, what is happening to inductor current? What's happening? So this is V0 here, okay, R here, IL of 0 minus, and this is I of 0 minus. Can you tell me what happens here? This is kept on the supply for long time. It has taken full current, then it is maximum current. Maximum current means what? Short circuit, short it. If this is short circuit, now what is the current of this loop? It's nothing but V0 by R. That's the first part. Then let us go for T0 plus. Switch is here. Now switch is moved to 2. Inductor cannot change its value. This is R. I of 0 plus. This is nothing but same, V0 by R. Whatever the current is here, that is a loop current. Here also, whatever the current, that is the loop current. What a nice idea to see. Though the switch position is changing, but the value of current is not changing. Okay, then t greater than 0. Switch is here. It is connected to position 2. Like this. And inductor should present. IL of I of t. Please remember, when you say inductor is present, you always say how much it is present with. What is the initial value? Otherwise, you know what happens? You may forget. Better to write it and keep it there. Now, how to write this equation? Ri L di by dt is equal to 0. No current, no voltage there. Then you may say, what happened to this? Nothing happens. It is there inside. Take Laplace transform R into I of s plus S into I of s minus IL of 0 plus is equal to 0. So if you take I of s common, R plus Ls is equal to V0 by R. Now take I of s and then inverse Laplace, you will get I of t. This is our argument. So depending on the position, depending on the switch position, we should take our equation. Initial current through inductor is inside the differential. Initial voltage across the capacitor is in the integral. So you don't need to worry, they'll take themselves along. If you are perfect in applying the differential equation and integral formulas for Laplace, you will understand. All that you need to remember is these two things: df of t by dt, s into f of s minus I of f of 0 plus integral f of t dt f of s by as. If you remember these two equations, that's more than sufficient. But remember, this is not infinity, this is 0. By mistake, if there is any initial value, split that integral and take only for this one. That's its two important suggestions in this solution. That's how we finalize the value of IT. For the circuit shown in figure, switch is at 1 for long time and then move to 2 for t is equal to 0. It is same as the previous, but only thing is, instead of inductor, I have put capacitor. So let us start. Here, here, this is the problem. Then what is the solution there? T0 minus here, switch is at 1. If switch is at 1 for long time, what will happen to capacitor? Okay. What will happen to capacitor? Capacitor is there for long time, so it will take total voltage here, plus minus. That's all. So what total voltage is here means what? Open circuit. What is the current here? 0 minus 0. Similarly, T0 plus, switch is moved here, 2 here, and then capacitor cannot change its value instantaneously. So what is the voltage here? Voltage is V0. What is the current there? Current is now V0 by R. V0 by R. Now t greater than this, what will happen? Switch is here at position 2, capacitor is also working. Just say V0 is there. This is I of t. So V0 is equal to Ri plus 1 over C integral 0 to t I dt. Where is this V0 coming from? This V0 is coming not from here, but from here. Because this initial value taken, I am not writing minus, I am straight away writing for 0. So V0 by S, R into I of S plus I of S by Cs. So solve for I of S, then if you take inverse, I of t will come. So this is our argument. For example, if you say I of S is here, V0 by S by R plus 1 by Cs. V0 into Cs by S here, SS cancel, RCS plus 1. So V0 into C by RC, if I take common, 1 plus RC, CC cancel, you can say I0 into 1 minus e power t by tau. That's your I of t, where tau is RC. Like this you can complete even inverse transform also. But complete solution will be generally asked in IES, but otherwise only some part will be asked in objective exam. Question number 5. For the circuit shown, switch is at 1 for long time and move to this. For example, look at the circuit V0, 1 here, 2, switch is here, 1 and 2. For our convenience, let us say R1, R2, L. Or this is R1, this is R2. Now what happens here? Slowly observe and write whatever he says. Solution. T0 minus. Where is the switch? You should be very careful and very cautious about what he says. This is the thing. Inductor, I am saying 0 minus is 0. R1 here, R2 here, plus minus V0. Good. Now once again read that. Switch is at A for long time. So at 1, this is 1. That means what? This is fully charged, full current, maximum current. That means short circuit. And what is the current he is saying? This is the current he wanted. So now this is I of 0 minus. How much is it? V0 by R1. So here also V0 by R1. That is about T0 minus. Coming to T0 plus, look at here, switch is there, but move to 2. Position 2 now. Now what will happen to inductor? Inductor current cannot change instantaneously. So whatever is here should come there. Now what will be this current? Because this current is same, so it is also not changing. So this is very interesting to see why it is not changing. Then T greater than 0. Look at over here. Nowhere connected. Everybody will come into picture. 1 is nowhere connected, 2 is connected, R1, R2, L. R1, R2, L. Now looking over here, for example, I of t, don't forget there is a current, please. IL of 0 plus is V0 by R1. Now if I take equations, R2 plus R1 into I of t plus L di by dt is equal to 0. Why 0? This is nowhere connected. Now if you take I of s, R2 plus R1 plus S into I of s minus I of 0 plus, and this you know V0 by R1. So please achieve what you call I of s, that's nothing but V0 by R1 into L also will be there, because this L is also multiplied there, by R1 plus R2 plus Ls. Now if I really have to solve it completely, now you look at the solution. He's not simply saying I of s, he's saying I of t. That means I need to take inverse. If I have to take inverse, what do I say? I of s is equal to V0 by R1 into L by L common S plus R1 plus R2 by L. Okay. This L you cancel. This you call it as I0 S plus where tau is L by R1 plus R2. Then if I take inverse transform, what should I get? I of t is equal to I naught into e power minus t by tau. This is the answer. That's the answer. What is the basic thought I am trying to guess? Very simple thought. Initially, it has developed a lot of current. Whatever the current it has developed, now it is discharging. Because if I draw this way, I am getting a current over here, discharging. So the very purpose of one place to other place, one position to other position is charge in one position, use it in other position. That's the logic, or that's the idea behind this problem, all the problems in single pole double throw. In one pole you are doing something, in other pole you are doing another purpose. If they have two purposes, we call it as single pole double throw. Question number 6. For the circuit shown in figure, switch is at 1 for long time and move to 2 at t equal to 0. And we need to calculate I of t at t greater than 0. So this is the switch, V naught here, or you say V. Then we have a resistor there. Then we have a capacitor there. Okay. Then inductor here. The current you need to see very carefully. This is I. This is R1, R2, C, L. Switch is very important. This is 1 and 2. So far switch is here, but now in this problem it is here. This is switch. Now let's enter into the solution. Okay, what is that? For example, T0 minus, I'll just draw like this, you don't worry. Just observe what I am doing and see what capacitor is there. See, I always keep open circuit, don't worry. If I understand it is short, then only I will short, otherwise I will leave it open. Opening and shorting is possible. If you short and then open is not possible. That's why I always keep open. Now I will read the question once again. So switch is at 1 for long time. This is 1. If the switch is at 1 for long time, whatever the V naught is here, because it could develop total voltage. This is R2. I of 0 minus is 0 because inductor could not develop any current. No current means open circuit. No current means open circuit. This means short circuit. So this is open circuit because it is maximum voltage. This is open circuit because no current. No current is open circuit. Maximum voltage also open circuit. That's about T0 minus. Now T0 plus, what am I doing? When I am going to T0 plus, this is the voltage as it is. This is the resistor as it is. Please understand, this is R1. R1 as it is. Now where is the switch moved to? This is the switch moved to 2. What will happen to inductor and capacitor? For inductor, this is cannot change. For capacitor also cannot change. Voltage across capacitor cannot change. Current through the inductor cannot change. Now what will happen? Now suppose if both are capacitors. So this is a capacitor 1, this is a capacitor. Suppose you have both the capacitors instead of a inductor. If this is also a capacitor, say C1, C2, then what will happen? This will be developed. If it is capacitor, what will happen? If it is a capacitor, second one is a capacitor, what happens is this could not develop any voltage. Here it could develop voltage this volt. This voltage is V0, this voltage is 0. 0 means what? Short circuit. So this short will be there, current is there. So what is the current flowing now? This is R2, there is V0, this is 0 plus, the current is V0 by R2. If it is inductor, that is a different story, but if it is a capacitor, this capacitor is open, this capacitor is short. And this being short circuit is continued, therefore voltage across this capacitor is 0 and voltage across this capacitor is V0. And that's why there is a current in this loop. Now t greater than 0, what will happen? If you say t greater than 0, V0 here, R1 here, okay, one capacitor here, another capacitor here, all capacitors are present, C1, C2. This is V0, this is R2. Now this is nowhere linked to the solution. Always you are observing in my SPDT, single pole double throw, first portion is to develop the charge, second portion is to discharge. That's a logic actually. Now in the process you just apply this current here, you call it as I of t, R2 into I of t minus or plus 1 over C I dt, call it as C2, 1 over C 1 I dt is equal to V0. When I say V0 is coming, this is not the V0, this V0 is coming, I can as well say 0 to t. Suppose if I don't say this V0, I should say minus there, okay. Here also minus, because there is no voltage here. Here there is no voltage, directly 0. This voltage has gone there, all are 0. So if I take Laplace transform, I2 of s plus I of s by C2s plus I of s by C1 of s is equal to V0 by s. Now solve for I of t and then solve for I of s. Then if we take inverse transform, I of t will come. That's the thought we have. So how to take inverse transform? It's just an ordinary procedure. You can take, for example, if I'll take another step, I'll give you to see what is really happening. I of s is common, r plus 1 by c1s plus 1 by c2s is equal to V0 by s. So I of s is equal to V0 by s by r plus 1 by c1s plus 1 by c2s. Then you take at least inverse transform from here. Like this you have to work out. That's our problem 6. For the circuit shown in figure, switch is at 1 for long time and then move to switch 2, position 2, and then we need to calculate I of t. The whole idea is we need to use inductor here to see what is going to happen. Here this is 1, 2, switch is here. Please be very clear about where is the switch. Yes. So here there is no resistor, no resistor. Only resistor here, R here, capacitor here. Now as usual, T0 minus V0 here, switch is at position 1, 2 here, then resistor here. Inductor is connected to this long time. Long time means maximum current. Maximum current means short circuit. Short. When this is short, maximum current. How much current comes here? This current is call it as inductor current V naught by R. V naught by R. What happens to this? This is not connected here. Not connected here means this is 0 voltage. Please remember, by taking large current, this is short circuit. By not taking voltage, this is short circuit. That's a highlight. T0 plus. Switch is here as well. Now switch is moved to 2. The status of inductor and capacitor does not change. Capacitor, inductor, they don't change. Inductor voltage will not change, capacitor voltage will not change, inductor current also will not change. That means I should call it as short circuit, this also short circuit. Where is the current he is asking? He is asking current here. Therefore, this is I of 0 minus is V naught by R. Here also I of 0 plus is V naught by R. Now what will happen? T greater than 0, V naught is here, but switch is here. Capacitor is there, inductor is there. R, L, C. This is I of t. Ri plus Ldi by dt plus 1 over C integral I dt is equal to 0. Then you may ask me, what is happening to the inductor current? Don't worry. Is there a voltage across capacitor? No. No means starting from 0. Then when you take Laplace transform, that will come I of s, s into I of s minus I of 0 plus I of s by Cs is equal to 0. That's all. Then in the place of this, you need to say V naught by R. Now solve for I of s, then by taking inverse transform, solve for I of t. That's the approach. Suppose if you want to know how is it going to be done, I'll just give another 2 steps. I of s is s plus Ls, okay, plus 1 by Cs is equal to V naught by R. Call this as, in the process, call this as some I naught. I naught by S plus Ls plus 1 by Cs. Then take inverse Laplace there. That's the approach for this problem. Question number 8. First, let me draw the circuit. Here is a battery, 120 volts. Nothing is given there. Then you have position 1 there and position 2 here. Okay. Then you have RL. So this is R, 20 ohms, 10 Henries, another resistor 40 ohms. All that he is asking is calculate this R. Okay. Now please read the question carefully. Inductor coil having 10 Henry's inductance along with 40 resistance. That means this is together. This is coil. Okay. If the voltage across the inductor coil, that means it is not simply across inductor, it is across the inductor coil. This voltage he is giving as 120 volts. Total voltage has come there. That's the meaning at T0 plus. So he is asking us to calculate R. Shall we start? This is not complete problem, only T0 minus. You see there. This is asked in GATE 2005. 2 marks given because it's slightly bigger problem for this. Now T0 minus we have to estimate plus 120 what will happen? Where is the switch? Switch is, this is the switch. Switch is initially at position 1. That means it is here. This is disconnected. This is 20 ohms. Inductor has taken full current. That means it will act as a short circuit. This is 40 ohms. And what is the voltage here? He said 120 voltage there at T0 plus there. He is not telling how much is there. This is, he is mentioning this is at T0 plus, but we are drawing for T0. So only thing that we understand at T0 minus is short circuit. Now at T0 plus, how is the circuit going to be? Circuit is going to be like this. R 20 ohms there. This remains shorted. This is 120 volts. Okay. So all that I want to know from here is how much is the current? Because it's acting as a short circuit, how much is the current? At T0 minus, how much is the current? 120 by 40 plus 20, 60. That means 2 amperes current. 120 is applied, inductor is shorted, but these two are there. So that is meaning of 20 plus 40, 60, 2 amperes. So don't forget this current. This current is still there as 2 amperes. This is 40 ohms. Now can you apply that and find out the voltage? So shall we apply this value and say how much is coming to? So what is happening is we have to calculate this value. Apply this KVL. When you apply KVL, what's happening is R plus 20 plus 40 into IL of 0 plus, that is the value, is equal to 0 is one answer. Okay. But he already said one thing. What he said, across this, he said it is 120. Okay. If he is saying across this voltage is 120, across the inductor, then what will be the current here? Okay. If the current is, instead of taking the total and say 0, you have another option. Second is, take this as 120, R plus 20 into 2 is equal to 120. Why 2? These 2 I am substituting there. So simply do it. R plus 20 is 120 by 2 is 60. R is 60 minus 20, that is 40. 40 means the option is C. Question number 9, switch is initially at position 1 for long time, then move to 2, calculate I for T 0 plus, and you need to see what is that I. Look at here, this is given in the exam. This is the voltage. Okay. V, then position 1, position 2 here, switch is there, capacitor, inductor, like this. This is R, C, L, R, C, 1 and 2. And he is asking current here. That is the question. Okay, ABCDs are given, options are given there. Now once again read the question. Initially it is at position A for long time. That means if I have to solve the solution T0 minus, here at switch, what will happen to the inductor? What will happen to the capacitor? And then what will happen to this one and this one? That's simple. Now this is given to the supply, so there will be some voltage, open circuit. There will be also, this is given for this, so it will be short circuit, maximum current. Inductor takes current, capacitor takes voltage, this also takes voltage. Call it as, instead of calling C and C, you can call C1, C2, but here C1 and C2 are equal. And this is R. Now, what is the voltage here? What is the voltage here? From here to here, the total is V. You can't simply say that voltage and this voltage is equal, because this is shorted, therefore this has no privilege, therefore the total voltage is 0, therefore this total voltage comes here. Once again, this is completely taking current. If this is short, this is gone, so it has no meaning. Otherwise, if you apply KVL, this plus this should be 0, the natural. So total goes here, though there is something here. So if I take 0 plus now, okay, now where is the switch going to? This is here as well, okay, this is here, there. Switch is at position 2. If the switch is at position 2, this is here, this is open circuit, this is short circuit, and this is anyway has no meaning. Now we have to understand what is happening to the current here. What is happening to the current? When you observe this, what is finally the current that you have in this circuit? This is nowhere connected, but this has already gone there. Now in this way, if you apply Kirchhoff's laws there, now this is R here, directly apply here, right? For example, you are going in the direction minus IR minus V is equal to 0. Therefore, I is equal to minus V by R. But what is happening there? This is one resistor you have, okay, another resistor is here. Because this is no voltage is developed from the beginning, you can say this is short circuit, this is also short circuit. Question number 10. Let me take the circuit, 24 volts, okay, 2 here, 12 volts there, Okay. Switch is here, one here. There is a resistor, inductor. There is a resistor and capacitor. 10 ohms, 2 Henrys, 2 ohms, 0.25 microfarads. Are you ready? Now at t is equal to 0 minus, I am taking the solution. Where is the switch goes to? Position 1. Position 1. This is position 2, 24. Position 1 is here. Okay. Switch is at position 1. This is here. Capacitor is here. Because it is connected to one of the supply. When inductor connected, this will act as a short circuit. When a capacitor connected, open circuit. Short and open. Now what is the current through inductor here? This is 10, this is 2. This is shorted, open. Therefore, the current in this is very simple. Inductor current is the circuit current. So I of 0 minus is equal to 12 by 10 plus 2, 12 by 12 is 1 ampere. Therefore, current through inductor is 1 ampere. 1 ampere. Current through inductor is 1 ampere. Please observe the question. He is asking, giving you only 1 mark. So, only 1 mark means you should be very quick. You should not waste time. 1 mark is equal to 1 minute. Now, let me take you for 0 plus. And 0 plus, now this switch is connected. This battery is connected. Switch is here. Resistors are there. This is not connected. This is shorted. This capacitor is open. So 10 ohms here. IL of 0 plus we have to say 2 ohms here. Now what happened? Normally students are tempted to say this is a loop 24 by 10 plus 2, 24 by 12. They want to say 2 amperes. But it's not so. This is a wrong approach. Why? Because inductor does not allow any change. This current is 1 ampere. This current should also be 1 ampere. So, examiner is tempting you to say 2, but don't say 2. Because actually according to calculations it is 2, but according to current cannot change across instantaneously, the answer is 1. 1 means option, according to our options, A is the option.